Hello students, welcome to my YouTube channel where we nurture and learn mathematics beyond boundaries. In today's video, we are going to cover the topic area under the curve as part of applications of integrals for class 12 CBSE applied maths. In the last few videos, we have covered the basic concepts of indefinite integrals, definite integrals and two applications of integrals, that is cost and revenue functions and the consumer and producer surplus. Before you move on to this video, go back and watch the video on at least definite integrals and then continue with this video. So let's get started with area under the curve. Now before we get into integration and using integration to find the area under the curve, let's do a quick recap of the kind of curves we have already done in grade 11, that is straight lines, circles, parabola. So x is equal to a is the generic equation of a straight line that would be parallel to the x-axis. Y is equal to b is the generic equation for any straight line that is parallel to x-axis. And ax plus by plus c is equal to 0 is a generic straight line equation. Now if you are given an equation like this, just transpose ax and c to the other side and bring the coefficient of y also to the other side to get it into a form y is equal to mx plus c. Why we are doing this is to understand what is the slope of this line. If the slope of the line is positive, that means this line is going to make an acute angle with the x-axis. And if the slope of the line is negative, it will make an obtuse angle with the x-axis. So for finding area under the curve, we just need the direction and the placement of the curves. That's it. We don't need to find the exact points to plot these curves before we find the area. So let's come to parabola now. X square equals 4ay is the generic form of a parabola that opens upwards. And if the right side is negative, that means the parabola is going to open downwards. Y square is equal to 4ax is the generic equation of a parabola that opens towards the right. And if the right side of this equation is negative, then the parabola opens towards the left. Now when we talk of parabola, there are two more important words that you should recall. The first is the focus and the second is the directrix. Let's consider x square equals 4ay. Now in this equation, this value of a tells you that the focus is going to be at 0, a. And the equation of the directrix is going to be y equals minus a. So it was just a recap so that when you come across questions where the word directrix or maybe the focus is used, you understand what it means. Now these are the two equations that are mostly used, x square equals 4ay and y square equals 4ax, and the corresponding negative counterparts you can remember. Now let's come to circles. Even though we have questions where we will be covering or using straight lines and parabola only, but I'll just do a quick recap of circles also just in case you have a question on this. This is the generic equation of a circle with center at 0, 0. So the center is at 0, 0 and r is the radius. Now this is the next generalized form of circle, equation of circle. For area under the curve, you might get a circle that has the center either on x-axis or y-axis. In this equation, if k is 0 and you just have h here, that means the center of the circle is on the x-axis. It could be anywhere on the x-axis where r is the radius. And in case r square is also written as h square here, that means the radius is also equal to h. So this would mean a circle like this where radius is also equal to h, and this is the center of the circle lying on the x-axis. Corresponding to this, if you have the equation of the circle given to you like this, now in this case the equation of the circle has center on the y-axis where k is there. Y minus k is square plus x square is equal to r square, r is the radius. Here also if r is specified as k square, that means this k and this k, the two values are equal. That means the equation of the circle is lying on the y-axis. The center of the circle is on the y-axis at a distance of k units from the origin. Right? In case the radius is not equal to h or k, then as per r you can plot the equation of the circle on the graph and then see how to find the area under it. Right? Now let's do some. Okay, before we move to the practice questions, let's understand the basic concept of how to find area under the curve. For example, this is the curve. If I take a marginal area in this space, this can be represented by dx and this is y. That means to find this entire area, if I integrate y with respect to dx with the limits whatever range is given in the question, for example it is a here and b here, so with the limits a and b I will get the area under this curve, right. Now let's look at this graph. Now I need to find this much area under the graph bounded by the values of y as a and b. Now suppose this is the marginal area that I consider. This space is called dy and here I can write x. So that means I need to integrate x with respect to y from a to b, right. Let's consider another equation of a parabola and two straight lines. Now if I need to find this area bounded by these two straight lines, the parabola and the x-axis, how I am going to integrate? Take a marginal space. This is what? Dx and this is y. So that means I need to integrate this curve y dx and bounded with x equals a and x equals 4. Understood? Next one. Here I have the curve like this. What is the equation of this parabola? It is x square is equal to 4ay, generic equation of the parabola opening upwards. Now this is bounded by y is equal to 4, y is equal to 1 and the y axis. So that means I need to integrate what? Draw this marginal area and try to understand what you need to integrate, because if you make a mistake here then the entire question will go wrong. So here it is dy and this value is x. So that means I need to integrate x dy bounded by y equals 1 and y equals 4. Understood? Okay, next. Now this parabola, what is the equation of this parabola? Y square is equal to x. Suppose it is given to you in the question. And you have a straight line also. Now you need to find the area bounded by this parabola and this straight line. How will you integrate it? With respect to x or with respect to y? So you need to first understand whether you need to integrate with respect to x or with respect to y, and then only proceed to solve the question. Now if I delimit these 2 points, I have the value of y as 1 here and y is minus 2 here. And if I take a marginal area like this, highlight this, I understand that this is what? Dy and this is my x. So that means I need to integrate x with respect to y from minus 2 to 1. Right? So this is going to give me the entire area from here. Once I have to use this equation and then I have to use the equation of the parabola also here. So that means it is going to be x from the equation of straight line, x for straight line minus the area bounded by this curve also, right. So you need to take away this area, because when you integrate the equation for the straight line you will get this entire area, but from this entire area you need to take away the area bounded by the parabola. So that means you need to subtract x of the parabola and integrate it with respect to y bounded by minus 2 and 1. Understood? Now let's look at the two parabolas here. If you have two equations of parabolas and you need to find the area bounded by both the parabolas, the required area is here. Here you can integrate with respect to x also and you can integrate with respect to y also. Both these are going to give you the same answer. So if you look at it, this is what? Dy and this is x. And if I do the other way around, then this is dx and the height is y. So I can use both the ways because the area is bounded by the origin and the point of intersection of the two parabolas. So I can use integral of y with respect to ds, or I can also use integral of x with respect to y bounded by the values of x and y. So for that, obviously you need to find this point of intersection of the two parabolas to put the limits here, right? So let's have a look at few questions to understand it better and how to solve these questions. The first question is, find the area of the region bounded by the curve y square equals 4x and the line x is equal to 3. Now y square equals 4a. What kind of parabola is this? Y square is towards the right. So that means I need to just draw a rough figure. I need not put in values of x and find values of y. I do not need exact graphs. For area under the curve, you never need exact graphs. You just need a indicative of what kind of shape you are going to get. So this is y square is equal to 4x and the straight line x is equal to 3. Where will be x is equal to 3? Parallel to y axis somewhere here. So this is x is equal to 3. Now the question says, find the area of the region bounded by the curve y square is equal to 4x and the line x is equal to 3. That means the required area is this. So after you have drawn a rough figure of the parabola and the straight line, shade the required area. Fine. Now how do we find the area? In this case, the required area is going to be twice of the area, because when we integrate, we get the area in the first quadrant. So if we can find the area of this first quadrant, we can just double it to get the entire area. So that means we will first integrate only with respect to first quadrant. Now if I take a marginal space here, this is dx and this is y. You may do this to get into the habit of which axis to choose for integration, which variable to use and how to write the equation for integration. That means I need to integrate y with respect to x. Now you are given the equation of the parabola as y square is equal to 4x. So that means y is equal to square root of 4x. That means 2 square root x. So here I need to write the expression for y, which is 2 square root x, and this is dx. Now this has to be bounded from where to where? X equals 0 till x equals 3. So write the limits also 0 to 3. Right? Now let's integrate this. Take this 2 out, it becomes 4. And integral of x to the power half is x to the power 3 by 2, and you have 2 by 3 here by the side, and you use the limits 0 to 3. That means it is going to be 8 by 3 and x to the power 3 by 2 minus 0, where x needs to be replaced by 3 for the upper limit. So this is what we need to calculate. How do we calculate 3 cube? 3 cube is, what is 3 cube? 3 cube is 3 into 3 into 3, 27. Now you don't know what is the square root of 27. You just need to find square root of this now. So it will be 3 square root 3. So it is going to be 8 by 3 into 3 square root 3. 3 gets cancelled and the answer is 8 square root 3 square units. Don't forget this square units, very important, otherwise you will lose half mark here. So the answer is the area, the required area is 8 square root 3 square units. Done? Okay, let's move to the next question. Now the next question says, find the area of the region bounded by the curve y square is equal to 4x, y axis and the line y is equal to 3. So the parabola is now y square equals 4x. So what kind of parabola is this? Y square equals 4x. If it is x square, then it is upwards. If it is y square, it is towards the right. So that means the parabola is going to be like this. And the line y is equal to 3. Now where is y is equal to 3? It is going to be parallel to the x axis. So just label them. This is y is equal to 3 and this is y square equals 4x. Done? Now what is the area of the region bounded by these two? Which area is needed? This is the required area. Again, draw a marginal area and try to understand. This is dy and this is x. The width is dy and the length is x. So that means you need to integrate x with respect to y and write the limits for y. Y is bounded from 0 to 3. So write the limits also, 0 to 3. So this is the required area. So what is integral of x with respect to y? So write this equation as x is equal to y square upon 4 and put it in this. So this becomes integral of y square upon 4 dy from 0 to 3. Take 1 by 4 out. So this is integral of y square, which is y cube upon 3 bounded by 0 to 3. So this becomes 1 by 4 3 cube upon 3. 3 cube, you cancel one of the 3, so it is 3 square, 9 by 4. 9 by 4 square units. So that means this is your answer. This is the area bounded by the parabola, the y-axis and the equation y is equal to 3. Understood? Easy? Great. So let's move to the next question. Find the area of the region bounded by the curve y is equal to x square and the line y is equal to 4. Now here the parabola will be, which parabola is this? X square equals y. That means the parabola is opening upwards. What is the equation of the line? Y is equal to 4. Where is y is equal to 4? It's somewhere here. Write these two equations on the graph also. Y is equal to x square and y is equal to 4. Area of the region bounded by the curve and this line. That means you need to find this entire area. Now how to understand, how to integrate this? So that means you draw a marginal space here and try to figure out how to integrate. This is what? Dy and this is x. And what are the limits for y? Y is bounded between 0 and 4. So that means you need to integrate x with respect to y bounded from 0 to 4. This x needs to be replaced from the equation of the parabola. So here x is equal to square root of y. And because this area is again half of the required area, so we can use double of this. So the required area is actually double of the area what we are going to find for the first quadrant. So it is twice of integral of square root of y dy from 0 to 4. Got it? Great. So let's solve this. So that means integral of square root of y is y to the power 3 by 2 and you have 2 by 3 by the side and the limits are 0 to 4. This becomes 4 by 3, y is 4. 4 to the power 3 by 2 minus 0. How do you calculate 4 to the power 3 by 2? So it is 4 cube and then square root of that. Square root cube of 4 is 64 and square root of 64 will give you 8. So that means this value is 8. 4 by 3 into 8, that gives you 8 4s are 32, 32 by 3 square units. So this is the required area bounded by the straight line and the parabola given here. Clear? Wonderful. So let's move to the next question. The area between x equals y square and x equals 4 is divided into two equal parts by the line x is equal to a. Find the value of a. So let's first draw a rough figure of this parabola and the line and try to understand what is given. The parabola is y square equals x. That means it is opening towards the right. So that means this is the required parabola. vertex at the origin. So we are only dealing with parabolas with vertex at the origin. So this is the required parabola, y square equals x bounded by x equals 4. So this is x equals 4, and this area is divided by the line x equals a into two equal parts. That means somewhere here we have the line x is equal to a, and it divides this entire area into two equal parts. So we need to find the value of a, right? So first let's find the total area that is bounded by this parabola and the straight line. It is going to be double of the area in this first quadrant. Now how do you find this? If you take a marginal area here, it is dx here and y here. That means the total area covered by the parabola and x is equal to 4 is integral of y dx. What is the boundation for x? From x is equal to 0 to x is equal to 4. So the limits are 0 to 4, and because we need to find the entire area first, so it is double of the area in the first quadrant. So you have to read the question very carefully. You might have questions where you need to find the area only in the first quadrant. You just integrate and it is done. Now here it will be 2 here because we need this upper half also and the lower half also. Now how do we write this y in terms of x? Because this is the equation, y equals square root x. So that means 2 integral of 0 to 4 square root x dx. What is the integral of square root x? It is x to the power 3 by 2, and we have 2 by 3 here, bounded by 0 to 4. So it is going to be 4 by 3 and 4 to the power 3 by 2. We just did this earlier also. 4 cube is 64 and square root of 64 is 8. So that means this becomes equal to 4 by 3 into 8, and this is 32 by 3 square units. So this is the entire area bounded by the parabola and the straight line x equals 4. Now the question says the straight line x is equal to a divides this complete area into two equal halves. So that means the area bounded by origin and this straight line and this parabola is half of this total area. So the area bounded by x is equal to a is area bounded by x equals to a and parabola is half of 32 by 3, that becomes 16 by 3 square units. Right, 16 by 3. So let's find this area now. So this area again can be found by integrating the same expression, but the limits are going to change. Here it was 0 to 4, but now we are going to use the limit from 0 to a. Here x is a. So let's do this. So it is integral of 0 to a square root x dx, and again it is twice of this because it is talking about first quadrant also and the lower quadrant also. So let's integrate this. It comes out to be 2 into integral of x is x to the power 3 by 2, and you have 2 by 3 here, bounded by 0 to a. This becomes equal to 4 by 3 a to the power 3 by 2, and then minus 0 you can just ignore. Now this area is equal to 16 by 3. So you can just equate this to 16 by 3. Label this as 1 and write here from 1 you have equated this to 16 by 3. So let's find the value of a now. 3 and 3 gets cancelled. 4 4s are 16. That means a to the power 3 by 2 equals 4. So what is the value of a? How to find this now? Because it is 3 by 2, you can do 2 by 3 power of both the sides. So that means to get a, you need to calculate 4 to the power 2 by 3. Understood? Now how to find 4 to the power 2 by 3? Again same, 4 square and then cube root of this. What is 4 square? 16. Now what is cube root of 16? It is going to be You don't actually need to find. It is going to be 2 root 2. 2, 4, 8, 16. Cube root means 2 root 2. So that means the value of A is 2 root 2. So this is your final answer. So I'll just show you the entire solution how we solved this question. First, plot a rough figure of the parabola and the straight line. Find the total area bounded by parabola and the straight line. In the first quadrant, whatever area you have, double of that is needed. So that's why there is a 2 here. Integrate the expression for y is equal to square root x. Find the total area. Now as per the question, x is equal to a is dividing this area into 2 equal halves. So you have already calculated the total area. Do half of it to get the area bounded by x is equal to a. Now again, simplify the expression by integrating with new boundaries, that is 0 to a. You get a to the power 3 by 2 and equate it to the half of area, that is 16 by 3. To calculate this last step, please do it carefully. A to the power 3 by 2 equals 4. Don't leave it here. You have to find the value of a. So that means because the exponent was 3 by 2, you take 2 by 3 power of both the sides. So it becomes a equals 4 to the power 2 by 3 and eventually the value of a is 2 root 2. Understood? Clear? Great. So let's move to the next question. If the area bounded by the parabola y square is equal to 16ax and the line y is equal to 4mx is a square by 12. Find the value of m. You need to find the value of m now. Now what kind of parabola is this? Y square equals 16ax. That means it is going to be right side parabola. Let me write the equation also. Y square equals 16ax. Y equals 4mx. Okay. Now just look at the equation of the line. You need not plot exact points, but you need to understand the equation of the line. Now because 4m is positive, this is positive, that means the slope of the line will be positive. That means it is going to make an angle, acute angle with the x-axis. It will definitely pass through the origin. So the straight line will be something like this. Got it? So let me write the equation of the straight line also here. And we have a graph like this. So this is the parabola y square equals 16ax and this is the straight line y equals 4mx. Now for finding area under the curve, we need the lower and upper limits. When we have a straight line and a parabola or maybe two parabolas, the next step after plotting the graph is to find their point of intersection. So let's focus on finding this point of intersection. We need to solve these two equations algebraically and find the point of intersection. Now the first equation says y square is equal to 16ax and the second equation is y equals 4mx. If I substitute y into the first equation, I get 4mx whole square equals 16ax. Square is 16, m square x square equals 16ax. 16 gets cancelled, one of the x also gets cancelled. So I have x equals a upon m square. Now if I substitute this x equals a upon m square in equation 2, I'll get the value of y. So let's do that. Y equals 4m into x. So let me put it as a upon m square. One of the m gets cancelled. So this is 4a upon m. So that means the point of intersection is a upon m square comma 4a upon m. Let me write the point of intersection here. It is a upon m square comma 4a upon m. So this is the point of intersection of the straight line and the parabola that is given to you. Now you need to find the area bounded by this parabola and the straight line. That means the required area is this. So this is going to be the area bounded by the parabola within this range minus the area bounded by the straight line. Getting? Because if you find only the area bounded by the parabola, you will get this entire area, but you need to take away the area bounded by the straight line to get the required area what you need. So this is the required area. So to get this, I need to find the difference of these two curves and then integrate. That means my integral, okay, before writing the integral, let's take a marginal space here. This is dx and this is y. So that means you need to use integral of y dx, and x is bounded from 0 to, what is the value of x here? A by m square. So this is what we need to use to find the required area. Now how do we write y? So it is integral of y. So first we need to write equation of parabola. What is parabola? Y square is equal to 4x. What is y? Square root of 16ax, and that comes out to be 4 square root a square root x. So let's write the y for the parabola, that is 4 square root a square root x minus, from the equation of the line again you need to take away y is equal to 4mx. So I'll just write 4mx, and you need to integrate this entire expression with respect to x using the limits 0 to a by m square. So this is the required area that you need to find out. Clear? Understood this? So this is very important that you write the correct expression here. Integration is easy, after that you can integrate for sure, but write the correct expression what is needed here, right? Now let's integrate this. So it is going to be 4 square root a, and integral of square root x is x to the power 3 by 2, and you have 2 by 3 by the side, minus 4m x square by 2, the whole thing bounded by 0 to a upon m square. Let's simplify it further. It becomes 8 by 3 square root a x to the power 3 by 2 minus 2mx square bounded by 0 to a upon m square. So let's put the upper limit and the lower limit. So it becomes 8 by 3 square root a. In place of x we need to put a upon m square whole to the power 3 by 2 minus 2m. In place of x again a upon m square whole square, and then minus 0. Don't forget the lower limit always. Now here this becomes 8 by 3 m square, and square to the power 3 by 2 becomes m cube. A to the power half, a to the power 3 by 2. So this is a to the power half, and this is a to the power 3 by 2. So if you add the exponents, half plus 3 by 2 is 4 by 2, which becomes a square. So this is what you get, right? Now this is 2m and a square upon m to the power 4. So let's simplify it further. This 1m gets cancelled here. So that means you can take a square by m cube out, and you have 8 by 3 minus 2 in the bracket. How much is 8 by 3 minus 2? 8 minus 6, it becomes 2 by 3. So that becomes 2a square by 3m cube. So you need to find the value of m when the area is given as a square by 12 square units. So you are given the area as a square by 12. So equate this to a square by 12, and you need to find the value of m. So let's do that. Now a square gets cancelled, and we have m cube, so it is m cube here. On the left side we have 2 into 12 by 3, 3 4s are 12. So this becomes m cube is equal to 2 cube. So that means the value of m is 2. Understood? So let's see what we have done. We have found the area of this parabola and taken away the area of the straight line. their difference needs to be integrated from 0 to the point of intersection, x coordinate of the point of intersection, that is a upon m square. And when you integrate, just keep on simplifying. Now equate it to a square by 12. You can write here that the given area is a square by 12, and then you get the value of m, that comes out to be 2. Understood? Great. So let's move to the next question. Find the area of the region included between the curve 4y is equal to 3x square and the line 2y is equal to 3x plus 12. So first let's understand what is the shape of this parabola. It is x square. So it is x square equals 4 by 3y. So that means it is going to open which side? Upwards. So that means the parabola is somewhere like this. Now the equation of the line 2x is equal to 3x plus 12. Compare it to y is equal to mx plus c. The slope of the line is positive. That means this line is going to somewhere intersect like this. It is making an acute angle with the x axis. Right? So just draw a rough figure. You need not find exact plotting points to plot the graph for all these curves. Now after this, whenever you have two curves like this, first understand what is the area. What area you need to find? You need to find this area. And to find this area, you need the boundary conditions, the lower and upper limit. That means you need to find the points of intersection of these two curves. So let me also mention these curves here. So it is x square equals 4 by 3y, what we have plotted parabola here. And the equation for the straight line is, let me bring this 2 to the other side. So it is y equals 3 by 2x plus 6. Now we need to find their points of intersection by solving both the equations algebraically. So let's do that. So it becomes, let me substitute this y from here. This is equation number 1 and this is equation number 2. So from 2, let me substitute y to equation number 1. So it will be what? 4 times, this is, I have written it here already, 3 by 2x plus 6 equals 3x square. Definitely you will get a quadratic equation because you need 2 points of intersections here. So let's solve this quadratic equation. Take the LCM 2. So it is going to be 12x plus 12 and this is going to be 6x square. So it is 6x square minus 12x minus 12 equals 0. That means x square minus x minus 1 equals 0. No, it is 2. X square minus 2x minus 2 equals 0. I just divided this by 6. Now here the factors are x square minus 2x I think we made some mistake here, so let me just take off this and let's have a look into the equation again. So it is 4, 3 by 2x plus 6 equals 3x square. Okay, so it is 6 4s are 24, 6 2s are 12 and 12 4s are 48. So first we need to take the LCM. So let's take the LCM and then simplify this again. So take the LCM, this is 3x plus 6 2s are 12 and you have 4 outside, you can cancel this with 2, this becomes 3x square, so it is 6x plus 12 2s are 24 equals 3x square. So now this becomes 3x square minus 6x minus 24 equals 0. Divide this entire equation by 3, it is x square minus 2x minus 8 equals 0. So what are the factors of 8? 4 and 2. Minus 4 and plus 2. So the factors are x minus 4 and x plus 2 equals 0. That means the two values of x are 4 and minus 2. So as you can see in the graph also, minus 2 will be here and 4 will be here. So let's find the complete points of intersection when x is minus 2 and when x is 4. What are the values of y? How can we find y? Y is 3 by 2 of x plus 6. So y is 3 by 2 of x plus 6 Put x as minus 2, it will become minus 3 plus 6, that makes it 3. So one point of intersection is minus 2, 3, and let's find the second point of intersection. It is going to be 3 by 2 into 4 plus 6. How much is 3 by 2 into 4? So it is going to be 2 2s are 4, 3 2s are 6, and 6 plus 6 makes it 12. That means it is 4, 12. So the 2 points of intersection are minus 2, 3, and the other one is 4, 12. So these are the 2 points of intersection. Now once we have the points of intersection, this gives us the limits that we need to use. So what is the required area? Area bounded by the straight line minus the area of the parabola. How do we understand that? These are the limits. So area bounded by the straight line minus the area bounded by parabola. This area you need to take away, right? So that will be the required area what we need to find out. And if you take a marginal area here, it is dx and this is y. So we are going to use integral of y dx. So let's do it. Integral of y dx, first the equation of the straight line. So we have integral of 3 by 2x plus 6. From this you take away the equation of the parabola y is equal to, okay, let's make it y is equal to something. So this can also be written as y equals 3x square by 4. So we need to integrate 3x square by 4. Put this entire expression in brackets and a dx here. And what are the limits? The limits are, what is the value of x here? Minus 2, and what is the value of x here? 4. So the limits are minus 2 to 4. So this is the required area. So be careful when you are writing the expression that needs to be integrated to find the required area. So let's integrate this expression. This becomes 3 by 2 x square by 2 plus 6x minus 3 by 4 x cube by 3, and the limits are minus 2 to 4. Simplify it wherever you can. So it becomes what? 3 by 4. Put x as 4. So it becomes 4 square plus 6 into 4 minus 1 by 4 into 4 cube minus, don't forget this lower limit also, putting the lower limit here. So it is going to be 3 by 2 into x is now minus 2. So it is minus 2 square upon 2 plus 6 into minus 2 minus 1 by 4 and cube of minus 2. Cube of a negative number is negative. So take care of the sign here when you have the limits, when you have negative values for the limits. So let's just simplify this expression. This becomes 3 by 3 into 4, that is 12. So it is going to be 12 plus 6 4s are 24 minus 4 square is 16 minus, within the brackets we have 2 gets cancelled, so it is 3 minus 12, and we have minus into minus plus, 2 2s are 4, 4 gets cancelled, 2. Let's just simplify. So this is 36 minus 16 minus, and in the brackets we have 3 and 2 5 minus 7. So the answer is 20 plus 7, that is 27 square units. So this is the required area. Understood? Great. So let's move to the next question. Find the area enclosed by the curve y is equal to minus x square. Now here you have a minus sign also, and the straight line x plus y plus 2 is equal to 0. So let's draw the rough figure first. So these are the coordinate axes. This is x square equals minus y. If you have x square equals y, it is opening upwards. So this case it is going to open downwards. Equation of the straight line, bring it to the form y is equal to mx plus c. So bring everything to the right side except y. It becomes minus x minus 2. Slope of x is negative. That means it is making an obtuse angle with the x axis. So the line is going to be somewhere like this. You don't need exact points, again I am repeating that. Now you need to find the area enclosed by this curve and the straight line. That means this is the required area. To find this area, the next step is to find their points of intersection. Let me first write the equations here. So this is y equals minus x minus 2 and this is y equals minus x square. Always write the equations of the lines or curves that you are plotting on the graph. So let's solve these two equations graphically first, algebraically first, and find their points of intersection. So from this parabola we have x square equals minus y. And what is y? Minus x minus 2. So it is minus of minus x minus 2, that becomes x plus 2. And that is again a quadratic equation. What are the factors? Minus 2 and plus 1. So it is x minus 2 and x plus 1. So that means the values of x are 2 and minus 1. When x is 2, what is the value of y? Y is minus x minus 2. So when x is 2, it is minus 2 minus 2, that makes it minus 4. When x is minus 1, y will be equal to minus of minus 1 minus 2, 1 minus 2, that is minus 1. Please take care of the plus and minus signs here when you are solving the equations algebraically. So the 2 points of intersection are minus 1 and minus 1, the first point in this quadrant. So it is minus 1 and minus 1, and the other point of intersection is 2 comma minus 4, which is in the fourth quadrant. So it is 2 comma minus 4. Now you need to find the area, and you already have the margins now, upper and lower limit. So let's try to first understand what we need to integrate with respect to what axis. So where is the marginal area? How do we do that? So this is the marginal area. So it is dx here and y here. So we need to integrate y with respect to dx, and the limits for x are going to be minus 1 and here x is 2. So you need to find this area limited by these axes. So let's do that. So it is going to be, the required area is integral of y dx. That means you first write the equation of the straight line and then take away the area of the parabola. Because when we are finding area by integration, we are getting the area between the curve and the axis. So here when you integrate the equation of the straight line, we get the area bounded by the x-axis and the straight line, the entire area. From this we need to take away the area bounded by the parabola and the x-axis, so that we get the required area, which is this area between the parabola and the straight line. Understood? So that means first we need to write y. In the form of y, we need to write the equation of the straight line. So it is minus x minus 2. From that, take away the parabola. What is parabola? Y is equal to minus x square. So it is minus of minus x square. And you need to integrate this entire thing with respect to dx. Now here, when you do the calculation, you will get the area as negative. But remember, area can never be negative. So let's first solve it. What are the limits? X is varying from minus 1 to 2. So it is minus 1 to 2. So let's integrate this. Minus x square by 2 minus 2x, minus into minus becomes plus, x cube by 3 bounded by minus 1 to 2. So this is minus 2 square by 2 minus 2 into 2 plus 2 cube by 3, and then the lower limit is minus 1. It is not 0, so don't make a mistake here. So it is minus of minus 1 square upon 2 minus 2 into minus 1. Take care of the sign when a negative limit is there, whether it is lower limit or upper limit. Take care of negative exponents. So this becomes what? This is minus 2 minus 4 plus 8 by 3 minus, in the brackets you have minus 1 by 2 plus 2 and minus 1 by 3. So this is minus 6 plus 8 by 3, minus into minus plus 1 by 2, minus 2 minus into minus plus 1 by 3, minus 6 and minus 2 is minus 8 and take the LCM as 6, 8 2 is 16, 2 into 3 and 3 into 2. So that comes out to be minus 8 plus 21 by 6. 6 8s is 48, minus 48 plus 21 upon 6. So this becomes minus 27 by 6, and when you reduce it to lowest form, 3 9s are 27, so it is minus 9 by 2. Now this is negative. So that means throughout you should use the absolute value symbol. When you are doing this entire process, you should use the absolute value symbol. Or here you can write as area cannot be negative. Why this is negative? Because it is on the downside of that x-axis. So the required area is, therefore area is 9 by 2. What is 9 by 2 in mixed form? 4 1 by 2. So you can write it is area is 4.5 square units. So this is your final answer. Understood? So be careful with the negative limits, be careful with the negative sign. When you get the area as negative, that means it is in the negative direction. Area cannot be negative. So just take away that negative sign and your final answer is 4.5 units for this question. Understood? Great. So let's move to the next question. Find the area enclosed by the parabola y square equals x and the line y plus x is equal to 2. So the parabola is y square equals x. Where will it open? Y square equals x means right side facing parabola. Y is equal to mx plus c. Get into that form. Y is equal to minus x plus 2. So that means the slope is negative. So this line is going to make an obtuse angle with the x-axis. So it will be something like this. Find the area enclosed. So you just need to find the enclosed area. That means this is the required area. Again, we need to find the boundary conditions. That is the point of intersection of both these curves. Let's write the equation of the parabola. This is y square is equal to x and the straight line is y plus x equals 2. Now let's find the points of intersection by solving these two equations algebraically. So y square is equal to x. Let this be equation number 1 and this is equation number 2. So y square is equal to x, y square equals to, what is x from here? X is 2 minus y. So I can just write 2 minus y here. So that makes it y square plus y minus 2 equals 0. The factors will be y plus 2 and y minus 1. So that means the values of y are minus 2 and plus 1. When y is minus 2, what is the value of x? X is 2 minus y. So x is going to be 2 minus 2, this becomes 4. So the value of x is 4. When y is plus 1, the value of x will be 2 minus 1. 2 minus 1 is 1. So value of x is 1. So the points are 1 comma 1 and the other point is 4 comma minus 2. So this point will be 1 comma 1 in the first quadrant and the other point is 4 and minus 2 in the fourth quadrant. So these are the points of intersection. Now let's see how to integrate with respect to what axis, what function and how to find the area. So if you look at this, you need to integrate here. So this is dy and this is x. So integrate this straight line first and take away the area bounded by the parabola. You get the required area. I hope by now you are used to it and you understand what we are doing. So that means we need to find integral of x dy. Write the equation of the straight line in the form of x. What is x equal to? X is 2 minus y. So we will integrate 2 minus y minus the equation of parabola in terms of x. So that is equal to just y square. It is straight away y square. So it is y square, and you need to integrate this entire thing with respect to y. Now what are the limits for y? The limits are, this is minus 2 and this is 1. So the limits are minus 2 to 1. So this is the required area. So let's integrate this. This becomes 2y minus y square by 2 minus y cube by 3, and the limits are minus 2 to 1. So let's put the limits now. 2 minus 1 by 2 minus 1 by 3 minus, take care of the negative limits, 2 into minus 2 minus square of minus 2 upon 2 minus cube of minus 2 upon 3. Again, cube of a negative number is negative, square of a negative number is positive. So don't make such silly mistakes here. So this becomes 2 minus 1 by 2 minus 1 by 3, and in the brackets we have minus 4. 4 by 2 it is 2, and this is 2 cube is 8. So it is minus into minus plus 8 by 3. So let's open the bracket and just simplify. So this becomes 2 here. There was a minus sign outside the bracket. So 4 plus 2 is 6. Minus 6, when you open the bracket it becomes plus 6. So that means it is 2 plus 6 minus 1 by 2 minus 1 by 3, and it is minus 8 by 3. So 2 plus 6 is 8, and take the LCM as 6. So it is going to be minus 3, minus 2 and minus 16. So it is going to be minus 21 by 6. So it is 8 minus 21 by 6. 6 8s are 48. 48 minus 21 by 6, it will be 27 by 6. And again 9 by 2, again you got the same answer, 4 by 2, 4.5 square units. So that means the required area is 4 1 by 2 square units. Please do not skip writing this square units, you will use half mark here otherwise. Got it? Okay, so let's move to the next question. Find the area bounded by the curve y is equal to square root x. I know you must be wondering how many questions. You're tired of doing so many questions, but I've tried to cover all the kinds of questions that you might get in your exam. So just watch the video till the end. There are very few questions left. We'll cover 2 PYQs also in the end. And we'll also have a look at the common mistakes that children make while solving questions related to area under the curve. So let's do the next question. Find the area bounded by the curve y is equal to square root x and the line x is equal to 2y plus 3 in the first quadrant and the x-axis. Now here it has specified that you need the area only in the first quadrant. So let's first draw the rough graph. So it is y is equal to square root x, that means y square is equal to x. What kind of parabola is this? Where will it open? It will open on the right side. So the parabola is here. Now equation of line is this. Write it in the form y is equal to mx plus c. Bring this 3. X minus 3, and you don't really need the slope, just need the sign. So if you bring it here, it is just this. So the coefficient of x is positive, that means it is a line with a positive slope, that means it is making an acute angle with the x-axis. So it might be something like this. So this is the equation of the line, x is equal to 2y plus 3, and this is parabola y square is equal to x. Now again we need to solve these equations algebraically and find the points of intersection. So let's do that. So y is square root of x, y square is x, and from the straight line we have x is equal to 2y plus 3. So y square equals 2y plus 3, y square minus 2y minus 3 equals 0. The factors are minus 3 and plus 1. So that means the value of y is 3 and minus 1. So when y is 3, the value of x will be, x is 2y plus 3. So 3 into 2, 6. 6 plus 3 is 9. So value of x will be 9 here. So that means the point is 9 comma 3. And when y is minus 1, x is going to be minus 2 plus 3. That means x is 1. So the point of intersection is 1 comma minus 1. So this point of intersection is 1 minus 1 and the other point of intersection is 9 comma 3. Now what is the required area? Area bounded by this and the line in the first quadrant. So that means we need to find only this area in the first quadrant. Not the entire area, but it is only this much area. So that means how do you figure out what function to be integrated with respect to what axis? You need to use this marginal area and try to understand. This is dy and this is x. So that means you need to use integral of x dy where the boundations for y are y is 0 and what is the value of y here? Y is 3 here. Right? So first we need to first write what is the equation of the straight line, because this will give you the entire area between the y axis and the straight line, and from that take away the area bounded by the parabola. So you will get the required area. Now we need to write the expression in terms of integral of x dy. So integral of first the straight line in terms of x. What is it? 2y plus 3. So it is going to be 2y plus 3 minus parabola in terms of x. It is y square minus y square. Integral of this whole thing with respect to y, and the limits for y are 0 and 3. So write this expression very carefully. So it is integral of 2y plus 3 minus y square bounded from 0 to 3. So let's integrate this. 2y square upon 2 plus 3y minus y cube upon 3, and the limits are 0 to 3. So let's put the limits. 2 into 3 square upon 2 plus 3 into 3 minus 3 cube upon 3 minus 0. So this becomes 2 and 2 gets cancelled, 9 plus 9 minus 9. This gets cancelled, so that means 9 square units is the required area. Understood? Easy? Great. So let's move to the next question. This is the last question. After that we will have a look at 2 PYQs. Even though this topic was added in the year 2025-26, this year only, but because integration has been there in the curriculum, so there are 2 PYQs also related to this. Okay, so the question is, find the area of the region bounded by the parabolas y square is equal to 4ax and x square equals 4ay. So this is very important because both the equations are for parabola. So what is the parabola? Y square is equal to 4ax is going to open right side, and x square is equal to 4ai is going to open upwards. So that means you need to find this area. Again, to find this area we need the point of intersection of the 2 parabolas. So how do we find that? So it is y square equals 4ax. This is equation number 1, and the other one, this is equation number 2. Y square equals 4ax. So in place of y, from equation number 2, y is equal to x square upon 4a. So I can put this in equation number 1. So this becomes x square upon 4a whole square equals 4ax. X to the power 4 upon 16a square is equal to 4ax. Okay. So let's solve this. X to the power 4, one of the x gets cancelled, so it becomes x cube, not x to the power 4. So we have x cube equals 16 4s is 16 into 4 becomes 4 cube, and a into a square is a cube. So this means value of x is 4a. Now if you put this value of x as 4a into this equation, so we get y equals x square divided by 4a. So it is 4a whole square upon 4a, that makes it 4a. That means the point of intersection is 4a comma 4a. So I'll just write the point of intersection 4a comma 4a, and again don't forget to write the equations of both the parabolas also. So it is y square equals 4ax and this is x square equals 4ay. Point of intersection is 4a and 4a. So we need to find the area between these two parabolas. Let's understand how to integrate this. Now this question, this can be integrated both using x-axis or using y-axis. It will give you the same answer, don't worry. So we can use either of them. So let's do it using integral of, if I take it like this is dx and this is y. So that means integral of y dx. So write both the equations using this. The first parabola, this one will come first because it is upper side. So y is square root of 4ax, and that can be written as 2 square root a square root x. This is the equation of this first parabola, number 1 parabola. The second one in terms of y, it is going to be x square upon 4a. So I need to subtract x square upon 4a and integrate all this with respect to x using the limits 0 to 4a. So this is the required expression for the area. Let's integrate this now. 2 square root a, integral of this is going to be x to the power 3 by 2 and you have 2 by 3 here, minus 1 by 4a, integral of x square is x cube by 3 and the limits are 0 to 4a. So let's put x as 4a here. 2 square root a, 2 by 3, 4a to the power 3 by 2 minus 1 by 12a, and this is 4a cube. So when you put x as 0, both the terms will become 0. So let's simplify it further. 4 by 3 and this is a to the power half. Now this is 4 cube. So again it is 4 to the power 3 by 2. Cube of 4 is 64 and square root of 64 is 8. So this becomes 8 here and then a to the power 3 by 2 minus 4 cube is 64, 64 upon 12 and it is a cube upon a. Here you get 8 4s are 32, 32 by 3 and it is a to the power 3 plus 1 4 by 2, that becomes square, minus you can divide this by 4, 4 6 are 24, 4 3s are 12, 16 by 3 a square. Take a square common, here and you will have 32 by 3 minus 16 by 3. How much is 32 minus 16? It is 16 by 3. So that means the required area is 16 by 3 a square square units. Done? Wonderful. So let's come to the PYQs for area under the curve. The first question is evaluate integral of x square dx and hence show the region on the graph whose area it represents. So let's first understand the question. It says evaluate. Evaluate means you need to find that area. So how to find the area of x square dx? What is x square? X square means it is the equation of a parabola opening upwards. So how to find the area bounded by this and show the region on the graph it represents? So it is x is going from 0 to 2. So there is x is equal to 2 and x is equal to 0. So you need to find this area. Pause this video right away and try to find this area. So how do we do that? So you just need to integrate x square with respect to x. So that means integral of x square with respect to x integrated from 0 to 2. That's it. What is the point of intersection here? X is 2. If x is 2, what is the value of y? Y is 2 square, that is 4. That means the point of intersection is 2, 4 and the other is origin. So the limits are from 0 to 2, x square dx. So this is the required area. So you need to evaluate also. So what is the integral? X cube by 3 and the limits are 0 to 2. 2 cube is 8. 8 by 3 minus 0. That means the required area is 8 by 3 square units. Now this is your required area. Now because the question says show the region on the graph. So this graph has to be proper with the x axis labeled, y axis labeled, equation of the parabola written. What is the parabola here? So you can just write x square here. Equation of the graph, equation of all the lines that you have plotted and the point of intersection. So all the points have to be there when the question says show it on the graph. Fine. So let's move to the last question. The area of the region bounded by the lines y minus 1 is equal to x, the x axis and the ordinates x is equal to minus 1 and x is equal to 1 is 2 square units. So let's see if the area is 2 square units. First you should understand the question and try to figure out is it really 2 square units. So let's draw the coordinate axis. Area bounded by this line. This is a straight line, not a curve. Y equals x plus 1. So it is just a straight line with a positive slope. That means making an acute angle with the x axis. So thus this is the rough graph of this line. Coordinates are x is equal to minus 1 and x is equal to plus 1. So that means you need to find this area and see if it is equal to square units, 2 square units. So that means you need to integrate x plus 1 with respect to x here, bounded by the limits minus 1 and 1. So what is the integral of this expression? It is x square by 2 plus x and the limits are minus 1 to 1. So it is going to be 1 by 2 plus 1, square of minus 1 is 1. So it will be 1 by 2 minus 1. Half plus 1 is 3 by 2 and half minus 1 is minus 1 by 2. It becomes 1 by 2. This becomes 4 by 2. So it is actually 2 square units. So that means the assertion is true. So this is a true statement. Now what is the reason? The area of the region bounded by the curve, the x-axis and the ordinates x is equal to a and b is given by this expression. So this expression is absolutely true and it is the reason for the first statement. So that means option A will be the correct answer, where assertion is true, reason is true and reason is the correct explanation of the assertion. Understood? So that's it what we have for questions in this video. Now we will just have a look at the common mistakes that children make while solving questions related to area under the curve. So the first common mistake is you need to draw a rough figure of the parabola or the straight line or circle or whatever is given. You need not plot exact points. Don't waste your time there. Second is focus on the points of intersection. So the focus should be on finding the points of intersection. Solve the two equations algebraically, find their points of intersection. The third is find the required area by carefully using either integral of x with respect to y or y with respect to x with proper limits. Then write the expression to be integrated in terms of the required variable and finally use definite integrals. Don't forget the lower bound, upper and lower limits. So don't forget the lower limit and take care of exponents where we have negative either upper or lower limits, right? So that was all about area under the curve. I hope you liked the video. The video was helpful to you. Don't forget to like the video and share the video with your friends who are also struggling to solve questions related to area under the curve. Subscribe to Boundless Maths if you have not subscribed so far. Keep watching, keep learning. See you in the next video.